Hey Hannah, I was just going to kind of work through this hopefully with you so that you can kind of see where these numbers are coming from. So this is the question. I pulled this from Webathon, and we're just going to go through and walk you step by step kind of what's going on here. And this is the information that question 6 gave us. It says, suppose we're testing for HIV and we've got 99.9% sensitivity and specificity, and we apply that to a population of 1 million people, okay? And we know that 3% of the population is infected with HIV, okay? So this is prevalence, okay, this 3%. So it's a fairly small portion of the population, okay? So when I'm dealing with a problem like this, I'm going to deal with the prevalence first, okay? I'm going to find 3% of 1 million people, okay? That's going to be the first thing that I do. And I would probably use my calculator to do that. But I know that if 3% of 1 million people have this, then there has to be a total of 30,000 people who should test positive, okay? Because we know that these 30,000 people actually have HIV, okay? If we know that, then that also should tell us how many people don't have HIV, okay? Because it's the rest of those million people, which is going to be 970,000, okay? So this is what the prevalence tells us, is it tells us, who should test positive and who should test negative. Now, we know that the test has a failure rate, so we don't expect it to get all 30,000 of these positive, and we don't expect it to get all 970,000 of those as negative. We're going to have some false positives. We're going to have some false negatives, okay? So sensitivity, if we look back at sensitivity and its definition, okay, it is the percentage of the positives that this test is going to find, okay? Its ability to find positives. So let's look at this. We know it's going to get 99.9%, and that's almost 100%. It's almost all of them. It's going to find almost all of these 30,000 people. But if I find 99.9% of 30,000 people, okay, that's almost all of them. It is 29,970 people, okay, out of these 30,000 it found. That means that 0.1%, okay, of that 30,000 people, they're going to get a false positive, okay, or I'm sorry, they're going to get a false negative. So the first thing I did in this calculation is I converted 99% to a decimal and I multiplied it by 30,000. Okay, so that's how I found the 29,970. And now I know this has to be 30. Okay, why? Because we know 30,000 people have HIV. Okay, we know that 99.9% of these people will actually get a positive test. That other 0.1%, okay, they're going to get a false negative. Okay, so let's go over here now and let's think about my people who really are healthy, who don't have this. This is also, this test has a specificity of 99.9%. So that means it's able to properly tag 99.9% of the negatives. So here, these people are healthy. So we want them to test negative, okay? And it's able to find 99.9% of them. So I would do the same thing. I would turn that 99.9% into a decimal and multiply it by that 970,000, okay? And if you crunch the numbers on that, okay, this is what you should get. The rest of those people, okay, they're going to get a false positive. So we're going to get 970 people who are healthy that get a positive test, okay? So where does that information come from? The number of people who have it come from the prevalence. The number of people who don't have it will be whatever the population is minus the people who do, okay? Now, where does this information come from? This comes from the sensitivity, Okay, whatever percent sensitivity we have, that's the percentage of these positives that will test positive, and the rest of these guys will get false negatives. Same thing over here when we think about the, this should say, I'm sorry, does not have. When we think about the does not have, okay, the sensitivity is that percentage of these people who will get a negative test, okay, because they don't have it, they should get a negative test. And the rest of these people are going to get false positives, okay? Now, we also want to go ahead and fill out this information for totals as we can, because we're going to need that later on for the NPV and the PPV. This total is asking me overall how many people will get a positive test. Okay, so we had these people over here who actually had HIV and they tested positive. They got a correct result. And then we have these people over here who didn't have it that got a false positive. So altogether, we had 30,000 people, 30,940 people who tested positive. Okay, going to do the same thing down here. I had 30 people who got a negative that shouldn't have, and I had 969,030 who got a negative and should have. Okay, so all in all, I have 969,060 people who ended up with a negative test. Okay, now remember what sensitivity and specificity did. They told us the percent of positives who actually tested positive. They told us the percent of negatives that actually tested negative. Now, PPV and MPV do something different. Instead of thinking about column totals, they think about row percentages. Okay, so PPV is going to tell us what percentage of these positives are correct. Okay, some of these positives are not accurate. Okay, these guys right here, they didn't have HIV, but they did test positive. Okay, so PPV, that's our percentage of positives that are accurate. So we're looking at, if we're thinking about percent as we always do as part out of a whole, that's my correct positives, okay, over my total positives. Okay, and then I can crunch that number on my calculator. So I've got 29,970 divided by 30,940, okay, and that equals 0.968. Okay, now I don't, let me see, particularly look and see if this wants this as a decimal. It does want it as a percent, okay, so it does want it as a percent. You might have to put that in, so there should be ability for some tolerance there. Depending on, there shouldn't be too much rounding going on in this case. Okay, so when I look at my MPV, I am calculating here the same thing for my negatives. Okay, what percentage of my negatives were accurate? So I have 969,030 over 969,060. Okay, and then I'm going to take my calculator and crunch those amounts. Which ends up being about 99.9% as well. We do it as a decimal, this is what we get. If we were to write these as percentages, we will be looking at this as a percent. And down here, 99.9%. Okay. Now the last question, part C, asks us how many people will test positive that are in fact disease-free. Okay, so that's your false positive. So we look up here. Okay, so these are my positive people. These are the people who should not have tested positive. So that's my 970 in this case. So I hope that that helps just a little bit. If you have more questions, let me know.